Okay, so first question for HL. We are on question 6 for SL. So two schools are represented by these points, A and B, 220 and 1424. A road represented by the line or with this equation passes near the school. So this is a road, these are schools. An architect is asked to determine the location of a new bus stop on the road such that it is the same distance from the two schools. First, find the equation of the perpendicular bisector of AB. Okay, so just to be clear, what we're trying to do here is find the line that the perpendicular bisector is the line that bisects these 2 points. So it goes straight through the middle. So the middle would be somewhere, I don't know, let's say, okay, let's just do this. So it's a line. That's not good actually. It's something like this. It's the line that goes straight down through the middle of the two of these. And then, so it says find the equation of this line and then determine the coordinates of the point on or where the bus stop should be located. So because this is a perpendicular bisector, it means every point on this line is the same distance from point A and point B. For example, if you put a point here, it's the same distance from A and from B because it's a perpendicular bisector. That's the definition of a perpendicular bisector. Therefore, the school, the bus stop, where are we going to put the bus stop? Well, it's going to be here because it's going to be on the road. The bus stop has to be on the road and it has to be equidistant, which is the same distance from A and B. So it's going to be there. So we're going to find the equation of this line and then find the point of intersection. Easy. Okay, so part A. First thing to find the perpendicular bisector, we need the midpoint. So we need to find the point that is between here. Let's call it M. So M, the point M, is halfway between A and B. So what we do is we say 2 plus 14 over 2, comma 20 plus 24 over 2. So that's x1 plus x2 divided by 2, comma y1 plus y2 over 2. This formula is in the formula booklet. Nice and easy. And it gives me a m, which is 16 over 2, which is 8. And then 44 over 2, which is 22. So this point M is at 8, 22, which looks about right. Okay, next thing, we need to find the gradient. Okay, maybe I shouldn't have used M because I'm going to use M for the gradient. Let me just change that, guys, if you don't mind, to P. Yes, it's a capital M, and it's not a big problem, but let's just call that P. This is, well, that's P there. This is P here. So the gradient, let's do gradient of AB. So the gradient of AB is, let's call it M, and it's y2 minus y1, y2 minus y1 over x2 minus x1. And this is 24 minus 20 over 14 minus 2, which is equal to 4 over 12 or 1 over 3. So this gradient here is 1 over 3, which means the gradient of, so this is M, therefore M perpendicular, the perpendicular gradient, is negative 3 over 1, if you like, which is just negative 3. Remember, to get the perpendicular gradient, you do the negative reciprocal. So you turn it to minus and flip it 3 over 1. Okay, now to find the equation of the line, we say y, I have the point and I have the gradient. I do y minus y1 equals m into x minus x1. This is the formula for the gradient of a line. If you want to use the y equals mx plus c and find c, that's absolutely fine, but I prefer this one because because I just sub in the stuff. So y1 is 22 because I'm using this point here. I'm using the point P. M is -3. X minus x1 is 8. There we go. So now I have y minus 22 equals minus 3x plus 24, because minus 3 times minus 8 is plus 24. He wants it in the form y equals mx plus c, so it's going to be y equals minus 3x plus 24 plus 22 is plus 46. Does that seem right for this equation of the line? Yeah, it does, because if you keep drawing that straight up, it's not going to reach the y-axis until quite high, which is the 46, and the gradient is -3, which, yeah, looks like a gradient of -3. Okay, so that's the answer to part A. Part B then says, find, well, what exactly does it say? Determine the coordinates of the point on or where the bus stop should be located. So all I need to find is where these two lines intersect. Now this guy is minus x plus y equals 4. So, okay, minus x plus y equals 4. I would prefer, this is the road, or let's just do that. So let's rearrange this. I'm going to write this as y equals, add x to both sides, so it's x plus 4. This line, the equation is y equals x plus 4. So to find where y equals x plus 4 and y equals minus 3x plus 46 meet, we're just going to equate them. Or on our calculator, we can just sketch them. So intersection, the intersection is at. Now you could solve this by simultaneous equations, but you have a calculator, guys. You have a GDC, which means you can actually draw the lines. So let's just do that. I'm just going to zoom out a bit. Let's press this. Give me my graph. So I'm going to draw x plus 4. That's that line. And then I'll draw minus 3x plus 46. So minus 3x plus 46. Can't see it, so let's just zoom. I like to try zoom fit. Not bad. That's where they meet. Find this point of intersection. Menu, analyze graph, intersection, lower bound, upper bound. So it's 10.5 and 14.5. 10.5, comma, 14.5. And that's the answer, because he said determine the coordinates of the point on or where the bus stop should be located. Does this make sense from just looking at the graph? 10.5 would be about here. Yeah. And 14.5 would be about here. Yeah, it looks about right. I mean, there's no marks for drawing this line, but it helped me to kind of check if I was right as I was doing the question, and these look pretty good to me. Okay, that's the question done. I'll see you in the next video.